All right, everyone, get ready because today we're going deep into machine learning.
Yeah, it's a fascinating field.
It really is, and you've given me a ton to work with,
Yeah.
including some stuff from Machine Learning for Dummies. So
Right book.
it seems like you really want to get a grip on this stuff,
Absolutely.
not just like a surface level understanding.
Yeah, machine learning is a lot more than a buzzword.
Right.
And it's changing a lot of industries.
Yeah, it's kind of behind the scenes in a lot of ways too.
Definitely healthcare, entertainment, finance, you name it.
Exactly. So for this deep dive, our mission is to kind of give you a solid understanding of machine learning, but going a little bit beyond just basic definitions,
Right.
talking about real world applications,
Excellent.
cutting edge techniques, all that good stuff.
I think people are surprised at the range of things that it touches.
Yeah, for sure.
That it's used for.
So are you ready to dive in?
Absolutely. Let's do it.
Okay, cool. Let's start with the fundamental question.
Sure.
What exactly is machine learning? We hear about all this stuff, algorithms, crunching big data,
Right.
but what's actually happening?
What's going on under the hood?
Yeah.
Yeah. So the Machine Learning for Dummies book uses this analogy that I really like. It says, computers manage data through applications,
Right.
and algorithms are like systematic recipes
I like that.
for processing information.
Okay.
So if you think about an app on your phone,
Yeah.
that's managing data. And the algorithm is like the recipe that tells the app what to do with it.
Okay, so it's kind of like step-by-step instructions almost.
Exactly. Yeah, step-by-step instructions.
Up
But
ahead.
machine learning kind of takes this analogy a step further.
Okay.
Because it's not just about following a set of instructions.
Right. Oh.
It's giving the computer the ability to learn and kind of come up with its own recipe.
Oh, so adapting the recipe based on the ingredients it has.
Exactly, based on the data it's given.
Interesting.
So instead of programming every single step, we're kind of teaching the computer to learn from the data and make its own predictions.
So it's more like setting a goal
Yeah,
rather than specific instructions.
right, exactly. It's like saying,
Okay.
here's what we're trying to achieve. Figure out how to get there.
Okay.
And that's where things get really interesting.
Okay.
Because this book talks about these 5 distinct tribes
Oh, okay.
of machine learning researchers,
Interesting.
each with their own kind of philosophy on how to achieve this learning.
Okay, I'm intrigued. Tell me more about these tribes.
All right, so you've got the symbolists.
Okay.
They're all about logic and rules.
Okay.
They approach learning like a detective solving a case,
Okay.
using symbolic reasoning to uncover patterns.
So very methodical, very step by step.
Exactly, yeah, very structured.
Okay.
Then you've got the connectionists.
Correct.
Now, they're a little bit different. They're inspired by the human brain.
Okay.
They use these things called neural networks, which are basically complex structures that mimic the way our brains process information.
So this is where we get into artificial intelligence.
It is partially, yeah, it's a subset of AI,
Right.
but it's important to remember that it's not about creating sentient robots,
Okay.
at least not yet.
Good to know. I was getting a little nervous.
Yeah, science fiction is not quite reality just yet.
Okay. Good. Good to know.
But machine learning is just one tool in the AI toolkit.
Right.
It's focused on learning from data,
Okay.
making predictions.
Got it.
Okay, so we've got the symbolists and the connectionists.
Right.
Who else is at this party?
Who else is in this machine learning tribe?
Well, we've got the evolutionaries.
Okay.
Now, as you might guess, they draw inspiration from Darwin.
Okay, so survival of the fittest.
Exactly, survival of the fittest algorithm.
Right.
So they use genetic algorithms that simulate natural selection to evolve solutions to problems.
Okay.
So they basically create a bunch of different algorithms,
Right.
and then they let them compete against each other.
Okay.
And the best ones survive and reproduce.
This is getting pretty complex.
It's fascinating,
Yeah.
but it's one of the things that makes machine learning so powerful
Okay.
is that there are so many different approaches,
Right.
and they all have their own strengths and weaknesses.
Okay.
Okay, then we've got the Bayesians.
Okay.
They're all about probability.
Okay.
These see learning as a process of updating beliefs based on new evidence.
Right. So constantly refining and adjusting.
Exactly. It's like how we learn as humans.
Okay.
We have a belief about something,
Yeah.
and then we see new evidence and we update our belief.
Oh, that makes sense.
Yeah. So Bayesian machine learning is all about using data to constantly refine and adjust the algorithm.
Okay, so that kind of ties into what you were saying before about how it's not just a set recipe. It's
Right.
constantly learning.
It's constantly evolving based on the data it's given.
Cool. Okay, so who's the last tribe?
Okay. The last tribe is the analogizers.
Okay.
They're all about finding similarities.
Okay. Between data points.
So, like, if you like this movie, you might also like this movie.
Exactly. Yeah, it's like recommending a book
Okay.
based on other books you've enjoyed.
So, like, finding patterns.
Exactly. Finding patterns and connections in the data.
Cool. Okay, so we've got our 5 tribes.
5 tribes of machine learning.
But the book also mentions this thing called the master algorithm.
Oh, yes, the Holy Grail.
What is that?
It's the hypothetical algorithm that could learn anything.
Oh, wow.
Think of it as the ultimate goal of machine learning.
Right.
A single algorithm that could combine the strengths of all 5 tribes.
That's pretty ambitious.
It is. It's very ambitious.
Yeah.
But it's what drives a lot of the research in the field.
Right, because if you could find that, then it could revolutionize everything.
Exactly. It changed the world.
Wow.
Now, this book specifically focuses on the Bayesian approach.
Okay.
Have you ever encountered Bayesian statistics before?
I've heard the term,
Yeah.
but I'm not really sure what it means.
Yeah, it can be a little intimidating.
Yeah.
But at its core, it's really about updating our beliefs as we encounter new evidence.
Okay.
So, for example, imagine you believe it's going to rain today,
Okay.
but then you look outside and you see a bright, sunny sky.
Yeah.
That new evidence would update your belief,
Right.
making you less certain about the rain.
Okay, that makes sense.
Right. So Bayesian machine learning is all about using data to constantly refine and adjust the algorithm's beliefs.
So it's always learning, always evolving.
Always learning, always evolving.
Got it. Okay, so we've got our data, we've got our algorithms, we've got our tribes even.
But our philosophies.
But how do we actually train these algorithms?
Yeah, how do we teach
Or like we can't just feed them data and hope for the best, right?
Right. It's not quite that simple.
Okay.
It involves using techniques like gradient descent,
Okay.
which is a way of guiding the algorithm towards the optimal solution
Okay.
by minimizing errors.
So it's kind of like giving it a goal
Yeah.
and letting it figure out the best way to get there.
Exactly. It's like giving someone directions to a destination,
Right. Right.
but without specifying the exact route.
So they can take different paths, explore different options.
Exactly.
Yeah.
They can explore and find the most efficient way to get there.
Okay, that makes sense. But how do we make sure that they're actually learning
Right.
and not just kind of wandering around aimlessly?
Yeah, we need to test them.
Okay.
We need to validate them.
Okay.
We need to make sure that they can actually generalize their knowledge
Okay.
and make accurate predictions on new information.
So it's like giving a student a test
Exactly.
after they've studied to see if they really understand the material.
Perfect analogy.
Okay.
And one of the big things we need to watch out for is overfitting.
Overfitting.
Yeah, it's where the algorithm basically memorizes the training data
Okay.
instead of learning the underlying patterns.
So it's like a student who crams for an exam
Exactly.
and can only regurgitate specific facts.
Yeah, they haven't really learned the concepts.
Right. They don't really understand.
Right, so they can't apply their knowledge to new situations.
Okay, so we need to make sure that our algorithms are actually learning and not just memorizing.
Exactly.
So how do we do that?
Well, we use techniques like cross-validation,
Okay.
where we basically split the data into different sets
Okay.
for training and testing.
So it's like giving them practice problems.
Exactly.
And then a final exam to
Exactly.
make sure they've really learned the material.
And that they can apply it to new situations.
Okay, that makes a lot of sense.
Good.
So we've covered the different tribes of machine learning.
We have.
We've talked about the master algorithm.
We've talked about the Holy Grail.
We've talked about how to train and validate our models.
We have.
Now, can we dive into some specific examples of algorithms?
Absolutely. Let's start with a few simpler ones,
Okay.
just to get a feel for how they work.
Okay.
Have you ever heard of perceptrons?
Perceptrons.
Yeah.
It rings a bell, but I'm not entirely sure what they are.
Okay, so they're one of the earliest
Yep.
and simplest types of artificial neural networks.
Okay.
So imagine a single neuron
Okay.
that takes in multiple inputs,
Okay.
weighs them based on their importance,
Okay.
and then produces a single output,
Okay.
either a yes or a no.
So it's like a basic decision-making unit.
Exactly. It's a simple building block.
Okay.
And while perceptrons are limited in what they can do,
Okay.
they form the foundation for more complex neural networks.
Okay, so it's like the first step.
It's the first step, yeah.
Okay, cool. What other basic algorithms are out there?
All right, so another classic one is the decision tree.
Okay.
Now, this one's a little bit easier to visualize.
Uh.
It's basically a flowchart-like structure
Okay.
that breaks down data into smaller and smaller subsets.
Okay.
based on specific features.
So it's like a series of yes or no questions.
Exactly. It's a series of questions
That lead you down the right path.
that lead you to the right answer.
Okay.
And then for tasks like spam filtering,
Oh,
there's
yeah.
the naive Bayes algorithm,
Okay.
which uses probability
Right.
to classify data based on the likelihood of certain features
Okay.
appearing in different categories.
So if an email contains words like free prize urgent,
Exactly.
it might flag it as spam.
Exactly. Because those words are more likely to appear in spam emails
Okay.
than in legitimate emails.
That's cool.
So it's a very effective technique for text classification.
Interesting.
But these are just the tip of the iceberg.
Okay.
There are many other more advanced machine learning techniques out there.
Right, because that's just like the basics.
Exactly the basic.
Okay, I'm ready for more.
Each with their own strengths and weaknesses.
I'm already feeling a little overwhelmed,
It's a lot to take in.
but in a good way.
It is a lot to take in.
Yeah.
But it's fascinating.
Yeah.
I mean, machine learning is such a vast and rapidly evolving field.
It is.
And it's easy to get lost in all the technical details.
Right.
But it's important to remember that at its core,
Yeah.
machine learning is really just about using data to create algorithms that can learn and adapt
Right.
and ultimately make our lives easier, more efficient,
I like that.
and maybe even a little bit more magical.
Okay, I'm officially hooked. So where do we go from here?
Let's keep going.
What other fascinating corners of the machine learning world are we going to explore?
I've got a lot more to share.
All right, let's do it.
Let's dive in.
Okay.
All right.
Oh,
So now that we've kind of laid the groundwork,
okay.
let's shift gears a bit and actually look at some of the real-world applications of machine learning.
Okay, yeah, because it's one thing to talk about these algorithms in the abstract,
Right.
but it's another thing to see how they're actually being used
Exactly.
to solve real-world problems.
And it's everywhere these days.
It really is.
I mean, we've all heard about self-driving cars and facial recognition,
Right.
but the Machine Learning for Dummies book actually goes deeper than that.
Oh, really?
It dives into how we even prepare the data
Okay.
before we even feed it to the algorithms.
So there's like a whole hidden world behind the scenes.
Exactly. There's a lot of work that goes into getting the data ready for machine learning.
Okay, so it's not as simple as just like dumping a bunch of numbers into a computer
Right.
and hoping for the best.
No. It's more like baking a cake.
Okay.
You can't just throw all the ingredients in a bowl and expect a delicious masterpiece.
Right.
You need to carefully measure and sift and mix everything.
To get the desired results.
Exactly, to get the right consistency, the right flavor.
I like that analogy.
So with data preparation, we need to do similar things.
Okay, so what are some of the key steps involved in preparing data for machine learning?
Well, one crucial step is handling missing data.
Okay.
Real-world data sets are often messy and incomplete.
Right, because like in a survey,
Exactly.
not everyone answers every question.
Right, some people skip questions.
Yeah.
Some data gets lost or corrupted.
Okay.
So we need ways to deal with those gaps in our knowledge.
So how do we fill those gaps without like skewing the results?
Well, there are a few different strategies.
Okay.
We can replace missing values with averages,
Okay.
or we can impute them based on similar data points.
So kind of like looking at what other people who are similar to this person answered,
Exactly.
kind of making an educated guess.
Yeah, and sometimes we can even use more sophisticated techniques like predictive modeling
Okay.
to estimate the missing values.
So it's almost like a detective game trying to piece together the missing information?
It's a lot like detective work.
Okay.
And then there's the challenge of creating new features.
New features.
Yeah, so sometimes the raw data we have
Okay.
doesn't provide the right signals for our algorithms to learn effectively.
Okay, can you give me an example of that?
Sure. So imagine you're trying to predict house prices.
Okay.
Having the square footage is useful,
Right.
but maybe combining that with the number of bedrooms and bathrooms
Okay.
creates a more informative feature
Okay.
that captures the overall size and functionality of the house.
Right, so it's not just about the raw data.
Exactly.
It's about kind of creating new data.
Creating new features that provide more nuanced insights.
That makes sense.
Okay. And lastly, we need to be aware of outliers.
Outliers.
Yeah, those data points that deviate significantly from the norm.
Okay.
So these could be legitimate data points,
Okay.
like a house with an unusually large lot size,
Okay.
or they could be errors that need to be corrected or removed.
Right, so like something that's just way off.
Exactly, something that's way off and could skew our results.
Okay, so outliers are kind of like the oddballs of the data world.
They are the oddballs. Sometimes they're interesting.
Okay.
Sometimes they're just noise.
Right. And we need to figure out which is which
Exactly. And handle them appropriately.
to build accurate models.
Exactly.
Okay, so we've gathered our data, we've cleaned it up, we've handled missing values,
We've tamed those outliers.
we've engineered new features.
We've done a lot of work.
What's next?
Now comes the fun part.
Okay.
Choosing the right machine learning algorithms and fine-tuning their parameters.
So this is where we actually get to like the machine learning part.
This is where the magic happens.
Okay.
But before we dive into that,
Okay.
let's take a look at some of the specific applications
Okay.
that are making machine learning so buzzworthy these days.
Sounds good. I'm particularly intrigued by image classification.
Image classification.
Yeah, like how do algorithms actually see the world?
Right. It seems like magic.
It really does.
But it all comes down to mathematics and clever algorithms.
Okay.
Image classification algorithms learn to identify patterns and features in images,
Okay.
just like our brains do.
But how do they do that? I mean, images are just a bunch of pixels, right?
They are, but those pixels contain a wealth of information
Okay.
about shapes, colors, textures, edges.
Okay.
And algorithms use techniques like edge detection
Okay.
and filters to extract these features
Okay.
and represent them in a way that computers can understand.
So it's like teaching a computer to see the world through a mathematical lens.
Exactly.
That's pretty cool.
And one of the most powerful tools for image classification
Okay.
is convolutional neural networks,
Okay.
or CNNs for short.
I've heard about CNNs.
Yeah, they're kind of the rock stars of image recognition.
Right.
They've revolutionized computer vision,
Okay.
achieving remarkable accuracy in tasks like object detection,
Okay.
facial recognition,
Right.
even medical image analysis.
So like helping doctors diagnose diseases?
Exactly.
Wow.
They can analyze medical images and identify patterns that humans might miss.
That's amazing.
It's pretty incredible.
Yes.
Speaking of facial recognition,
Okay.
that's one application that always makes me think about both the incredible potential
Right.
and the potential pitfalls of machine learning.
Right, because it can be used for good,
Exactly.
but it can also be misused.
Absolutely. It's a powerful technology.
Right.
With a wide range of applications.
Yeah.
From security and surveillance
Mm.
to personalized marketing
Okay.
and social media.
Yeah, it's everywhere these days.
It is, but it also raises important questions
Okay.
about privacy
Yeah.
and the potential for misuse.
Right, because if it's not used responsibly,
Exactly.
it can be very dangerous.
Absolutely.
Mm.
So it's a reminder that with any powerful technology
Right,
comes a responsibility to use it ethically
for sure.
and thoughtfully.
Okay, so let's move on to another fascinating area.
Okay.
Sentiment analysis.
Sentiment analysis. This is a fun one.
Yeah, how do companies analyze online reviews
Right.
to understand customer feedback?
Yeah, I mean, there are millions of reviews online.
Right.
How do you make sense of all that data?
Yeah, it's overwhelming.
It is, but that's where sentiment analysis comes in.
Okay.
It's like teaching a computer to read between the lines
Okay.
and understand the emotional tone behind text.
So it's not just about identifying positive or negative words.
Yeah.
It's actually grasping the nuances of human emotion.
Exactly. It's about understanding the sentiment,
Wow.
the feeling behind the words. So sentiment analysis algorithms use techniques like natural language processing,
Okay.
or NLT for short,
Okay.
to analyze text, identify keywords and phrases,
Okay.
and determine the overall sentiment.
So is it positive, negative, neutral?
Exactly.
Okay, that's amazing. So a company could use sentiment analysis
Right.
to track how customers are reacting to a new product launch
Absolutely.
or to identify potential issues before they escalate.
Exactly. A very powerful tool for businesses
This sounds like it.
to understand customer perceptions, improve products and services,
Okay.
and even predict market trends.
Wow. It's incredible how machine learning is being used to decode human emotions
It is.
and extract insights from the vast sea of online text.
It's like having a digital detective
Yeah.
reading through all those reviews for you.
Okay, let's talk about something that's probably on everyone's mind.
Okay.
Recommender systems.
Recommender systems.
Yeah, like how do websites like Amazon and Netflix know what products or movies we might like?
Right. It's the million-dollar question.
Yeah, because they're surprisingly accurate.
They are.
Like eerily accurate sometimes.
They can be, but it's all thanks to machine learning.
Okay, so how do they do it?
Well, they use sophisticated algorithms
Okay.
that analyze our past behavior,
Okay.
our purchases, our ratings, our browsing history,
Okay.
to create personalized recommendations.
So they're like digital detectives.
Exactly.
Piecing together clues from our digital footprints.
To create a profile of our preferences.
Okay.
One common approach is collaborative filtering,
Okay.
where the algorithm looks for similarities between users
Okay.
based on their past ratings.
So if you and I both gave 5 stars to the same movies,
Exactly.
the algorithm might assume we have similar tastes
Right.
and recommend movies that one of us liked but the other hasn't seen.
Exactly. It's like tapping into the collective wisdom
Okay.
of a community of movie lovers.
I like that.
And then there's content-based filtering,
Okay.
where the algorithm focuses on the characteristics of the items themselves. So, for example, if you've watched a lot of action movies,
Right.
the algorithm might recommend other action movies with similar themes,
Okay.
actors or directors.
So it's kind of like blending
Can
our
create-
individual preferences
Right.
with the characteristics of the items.
To create a personalized experience.
That's cool.
It's a testament to the power of machine learning
Yeah.
to create experiences that are tailored to our unique tastes and interests.
But beyond these individual applications, isn't there a bigger picture to all of this?
Yeah, I mean, what's the ultimate goal of machine learning?
Like, where is all of this headed?
Right. That's a question that continues to spark debate
Okay.
among researchers and philosophers alike.
Okay.
Is it simply to create machines that can perform tasks more efficiently than humans?
Right?
Or is there a deeper aspiration
Okay.
to understand and replicate the human mind itself?
That's a pretty deep question.
It's a question that we're still grappling with.
Yeah.
And there's no easy answer, but it's something that we need to keep in mind.
As we develop these increasingly powerful technologies.
Exactly. We need to be mindful of the potential consequences.
Okay, so let's continue exploring the specific ways
That's good.
that machine learning is being applied in various fields.
Okay, are you ready to delve into the world of advanced machine learning techniques?
I think so. Let's do it. Okay, so we've got the basics down.
The foundations.
We've looked at how to prepare the data,
Right.
and we've seen some real-world applications.
It's amazing how much machine learning is being used already,
It really is.
and we're only just scratching the surface.
So now I want to know about those more advanced techniques.
Okay.
Like, what's beyond those basic algorithms?
Well, think of it like leveling up in a video game.
Okay.
You've mastered the basic moves, now you're ready for the advanced powers.
Okay, so what kind of powers are we talking about?
Well, one really interesting area is similarity measures.
Okay.
Algorithms like key nearest neighbors use these things called distance metrics.
Distance metrics.
Yeah, basically mathematical measuring tapes
Okay.
to find data points that are similar to each other.
So it's like grouping things together based on how close they are?
Exactly.
Yeah.
Yeah, like grouping stars into constellations
Okay.
based on their proximity in the night sky.
That makes sense.
So by identifying clusters of similar data points,
Yeah.
we can start to understand the underlying structure of our data
Okay.
and make predictions about new data points based on their similarity to existing ones.
So, like, if this data point is similar to these other data points,
Right.
then it's likely to behave in a similar way.
Exactly. That's the basic idea.
Okay, that's pretty cool.
It's a powerful technique.
What other advanced techniques should we be aware of?
Well, another powerful class of algorithms is linear models.
Linear models.
Yeah, these models use weighted sums of features to make predictions.
Okay, so can you give me an example?
Sure. Imagine you're trying to predict the price of a house
Okay.
based on its size, location, and number of bedrooms.
Right.
A linear model would assign weights to each of those features
Okay.
and use a simple equation to estimate the price.
So it's like a mathematical balancing act
Exactly.
Yeah.
Yeah, finding the right combination of weights.
to make accurate predictions.
Precisely.
Okay. And we can make these models even more complex, right?
We can add more complexity
Mm-hmm.
using techniques like polynomial expansion,
Right.
which basically creates new features that capture nonlinear relationships in the data.
Oh, okay. My brain is starting to hurt a little bit,
It's a lot to take in,
but in a good way.
but it's good to stretch those brain muscles.
No else is there.
All right, you ready for this?
I think so.
Support vector machines.
Support vector machine.
Yeah, or SVMs for short.
Okay.
These algorithms are like expert swordsmen,
Swordsman. Okay.
finding the optimal dividing line between different classes of data.
So, like, imagine you have a basket of apples and oranges,
Okay.
and you want to separate them.
Right.
An SVM would find the perfect line that cuts through the basket, leaving all the apples on one side and all the oranges on the other.
That's a great analogy.
Okay.
SVMs are incredibly powerful for classification tasks.
So, like, figuring out what category something belongs to.
Exactly.
That's really cool.
And they're especially good at handling high-dimensional data.
High-dimensional data.
Yeah, data with lots of features,
Okay.
like images or text.
Oh, okay. This is all so mind-blowing. Are there any other techniques you want to touch on?
We can't forget about ensemble methods.
Ensemble methods.
Yeah, they're like the team players of the machine learning world.
Team players.
Instead of relying on a single model,
Okay.
ensemble methods combine multiple models.
To improve accuracy.
Exactly, to get a more robust prediction.
So it's like having a panel of experts
Right.
instead of just one.
Each offering their unique perspective
Okay.
to make a more informed decision.
I like that analogy.
Techniques like random forests and gradient boosting machines are good examples of this.
Okay, so we've gone from simple perceptrons to these complex ensemble methods.
We've covered a lot of ground.
It's clear that machine learning is a very powerful tool.
It is one of the most powerful tools we have.
But what are some of the limitations?
That's a great question.
Because it can't be the answer to everything, right?
Right. It's important to remember that machine learning,
Yeah.
like any tool, has its limitations.
Okay.
One major limitation is that algorithms are only as good as the data they're trained on.
Garbage in, garbage out.
Exactly. If the data is biased or incomplete, the results will reflect those flaws.
So it's not a magical solution
Right.
that can fix bad data.
No. You need good data to get good results.
That makes sense.
Another challenge is that many machine learning models are kind of like black boxes.
Black boxes.
Yeah, we can see what they predict,
Okay.
but it's often difficult to understand why they make those predictions.
So it's like having a magic 8-ball
Exactly.
that gives you answers,
Yeah.
but doesn't explain its reasoning.
Right, which can be a problem.
Especially in situations where transparency is important.
Absolutely.
You need to be able to understand how the decision was made.
And lastly, it's important to remember that machine learning is just one piece of the puzzle.
Okay.
It's a powerful tool,
Right.
but it's not a replacement for human expertise,
Okay.
creativity, and critical thinking.
So it's about finding the right balance,
Exactly.
leveraging the power of machine learning,
Right.
but still maintaining human oversight and judgment.
Absolutely. The future of machine learning depends on our ability to use it responsibly
Okay.
and ethically.
And to recognize both its potential and its limitations.
Exactly.
Well, this deep dive has been incredibly insightful.
I'm glad to hear that.
I feel like I've gone from feeling totally intimidated by machine learning to actually understanding the basics.
That's great to hear.
And even getting a glimpse into the future.
It's an exciting field,
It really is.
and it's only going to get more exciting.
So where do we go from here?
Well, the journey doesn't end here. This is just the beginning.
Okay.
There's so much more to explore,
Okay.
from cutting-edge research to emerging applications
Okay.
that are constantly pushing the boundaries of what's possible.
It definitely makes you wonder what the future holds.
It does. It's an incredible time to be alive.
It really is. Well, thanks for guiding me through this deep dive.
My pleasure.
I feel much more equipped to navigate this world now.
That's what we aim for.
And for those of you listening out there,
Yes.
we hope you've enjoyed this exploration of machine learning.
Absolutely.
And maybe you'll be inspired to learn more.
You never know.
Maybe you'll even be the one to develop the next groundbreaking algorithm.
That changes the world.
That's what I'm talking about.
That's the dream.
All right, that's it for this episode of The Deep Dive.
Thanks for listening.
Thanks for joining us, and we'll see you next time for another deep dive into the world of knowledge.
See you then.